Hello everyone and welcome back to another video. Today we'll be taking a look into the chessbot which we have been creating for the past couple of videos into even more detail. So in this particular video we're going to continue with our legal moves functions. So far, just to recap, we've gone over the return of the possible moves, castle, whether the king is in check, as well as the legal moves. Okay, and now we'll finish it off by looking at the final couple of functions, namely the legal king moves, whether it's checkmate or not, and all possible moves. Okay, so let's have a quick look at the actual program. Okay, so if you want to follow along on GitHub, as I would recommend you do, it's basically from line 366 all the way till line 375, which we will be looking at today. Okay, so let's start with the legal king moves first. So pretty much the aim of this function is just to return which moves are legal for the king. So what we went over a few videos ago was the legal moves for general pieces. However, the legal moves for the king, as you would imagine, are going to be different. Since for the legal moves for the other pieces, they basically depend on whether the king has legal moves. Because, for example, if it's a check, then the king has to move, or a piece has to be captured. All of that which we will deal with in this particular legal moves function. Okay, so initially what we take as parameters is firstly the king location, the board, and also the piece locations. The board and piece locations are being taken as parameters to many of these functions, since they're pretty much imperative for anything which we're doing. Okay, so initially, what we're going to do is we first need to determine whether one of the legal moves for the king is castling, so whether it has castling rights or not. So for this, we basically call the self.castle function, which we went over in a previous video. But if the self.castle function returns true, i.e. castling in that particular direction is valid, then we append that particular position to the new king positions. Okay, and now, however, aside from castling, the king still has other legal moves. So over here, this basically generates all possible moves which the king could make, theoretically. So namely, these are moving one square in each of the 8 directions which it can. So this basically for I and j in range -1 to 2, -1 to 1. And as long as that particular square is not occupied by a piece of the same color, so that basically means as long as the color of the piece is not equal to the color of the king, and as long as that particular square is free, like if either one of these conditions are met, or the square is empty. If any of these conditions are met, then it's basically a possible move, okay? And now, after the possible moves, one more thing which you might notice is that within these possible moves, we're also appending the current king position into it, since when I is 1 and j is 1, the value of king lock plus I and king lock plus j, this will basically be the current king position. This is not like a mistake. The reason why we're doing this is because a bit later on, it'll basically come in handy to see whether the current position is in check or not. Since the current position would be denoted by king lock plus 0 and king lock plus 0 over here as well. Okay, so now for each of these end coordinates within the possible array, and remember this possible array is just made up of all the possible moves which it could make, all we basically need to do is, this basically carries out the move on a set of, on the board. So, however, we need to basically take a copy of the board, since we don't want to be affecting the board which is being passed as a parameter over here. Since if we did that, it would basically affect the future results. So we basically take a copy of piece locations as well as the board, and then we perform the move, excuse me, and we basically perform the move with the starting king location, the final king position, as well as the piece locations copy and the board copy. After we do this, we basically determine whether the king is in check or not, which we covered in the previous video. Now, we basically have res and res 1. So res basically means that whether the king is in check. So if the king is not in check, then we append it to valid. And res 1 means whether the king is in double check or not. So now, whether the king is in double check, that's a special condition of it being in check. Since a bug which I was facing when I was actually programming this was, like I handled double check to being the same as a single check, which created the error of basically, what was happening is that if a piece could capture one of the pieces which was causing the check, that was considered to be a valid move. However, clearly it wouldn't be. Since if you added a double check, just capturing one of the pieces isn't good enough, since we need to evade the check from both pieces. So if it's a double check, then the king has to move, basically. So we basically set these particular variables to being is double check, is check, pinned piece is basically the piece, and the piece is basically the result of attack square from the self is king and check function. Okay, and now attack square is basically square, and then finally what we do is we basically just return all of these to its parent function. And now the parent function which calls legal king moves is legal moves, which we went over in the previous video, I think. Okay, so that's basically the legal king moves now. Okay, so now we need to go over the is checkmate function. So let's have a quick look at this function. So pretty much, it's pretty self-explanatory what the function does. It basically just determines whether the position is checkmate or not. So the need for such a function is pretty clear, since it's the aim of the game, right? Just whether it's checkmate or not, and then we need to determine whether it's checkmate just so we can finish the game. So basically, what we initially need, the criteria for checkmate is that there are essentially no legal moves. So what we first need to do is this is checkmate returns a Boolean variable, whether it's check and whether it's checkmate basically, and that comes from two criteria. First of all, it has to be a check. Second of all, the king has to have no possible moves which can make, as well as it being a check. And third of all, those two alone aren't sufficient for it to be checkmate. Third of all the other pieces on the board cannot stop the checkmate in any way. So the way in which we do this is we have two criteria, whether it is check and whether the length of all the possible moves which we can make is 0. If both of these are met, only then will we return true, and true denotes checkmate. Otherwise we'll be returning false, and then it won't be checkmate. Okay, so what we initially do is we basically determine the legal king moves first, and now if there are any legal king moves, so if there are any legal king moves, then we basically just automatically return, since there's basically a legal king move, so it cannot be checkmate. And all of these variables are pretty much, the need of them has been explained earlier, but now we'll be looking into is double check and is check into more detail. So first of all, only if it's check, then we should consider the pieces, the moves of the other pieces, since if it's not check, then there's no way it can be checkmate, right? So then what we basically do, only if it's check, then what we do is we basically determine which vector the check is coming from. So for that, we basically do a vector subtraction of the attack square as well as the king location. And now what we do is we basically also determine which piece is the square which is giving the check. And now if the piece is less than 2, then i.e. if the piece is a pawn or a knight, then we basically, the only possible square which another piece can go to will be that particular square which the check is coming from. So let me just explain what exactly I mean by this through an example. Okay, so consider this particular position which we have over here. So what we basically have over here is a pawn which is checking the king. And now, since this piece is a pawn, the only possible way in which we can get out of this check is by moving the king or by capturing the pawn. Since if the piece was something else, like for example, let's say a rook, so let's say if I were to move the king over here, then what would basically happen is, oh, sorry, I just realized I just made a illegal move, so which is why the program basically stopped, so this game was finished. But anyways, back to what I was explaining. So let's say if the check is coming from either a pawn or a knight, then there's basically no way in which we can stop the line of attack from the check. We either need to capture the pawn or knight, or we need to move our king. So, but however, let's say the king was in this particular square, where it's being attacked by the rook. In that particular case, we can capture the rook, as well as moving another piece to one of these squares, which basically stops the check from happening. So that's basically what we have over here. What we're doing is we're just determining whether if the piece is either 1 or 2, which means it's a knight or pawn, then the only possible square in which another piece can go to will be the square where the check is coming from. However, if it's another piece, then what will basically be happening is for every square within within the line of attack of the actual check, that particular square is valid. So for iron range scale, allow dot append vector addition of attack square, vec2 and I, where I is basically the scale. So this basically appends every single vector, which is an addition of the starting vector as well as the final king position. And now for each of the vectors in allowed, then we basically need to determine whether that square can be attacked from one of the pieces in the color which we're checking for it to be checkmate or not. Since basically what this means is that if one of the pieces of the color which is being checkmated, if one of those pieces can attack a square, which is inside allowed, by attacking a square basically mean that whether it can move to that particular square. Maybe I'll just add that as a comment, i.e. the piece can move to that square. Then it basically means a piece of the same color as the king can basically move to the square. Then what this means is that it can't be checkmate basically, because a piece can move inside the line of attack from the piece to the king. And then therefore, if the square can be attacked, then we return false. Now, if after looping through this every single time, we basically find that we haven't returned false yet, and if the length of the possible moves is 0, and if it is check, then we return true, i.e. it is indeed checkmate. Okay, so now the final function which we're looking at is just all possible moves. So what this basically does is this function returns all the possible moves which can occur from a certain position. So this is slightly different to the return possible moves. So the return possible moves just, it doesn't apply any brain, it just returns all moves which could happen. And then all possible moves needs to factor in for the legal moves as well. So what we basically do is, we need to first determine if the piece is a king, if the piece number is basically 6, it's a king. Then we have a special function which determines the legal moves, which is legal king moves. And then otherwise, what we basically do is, if it's not a king, then what we do is we basically go through all the other pieces, and then we take the legal moves from there. Okay, but now one more thing inside this all possible moves is it just differentiates between whether it's check or not. So basically, if it's check, then what will basically be happening is that we can only do a move from another piece if one of the squares which that piece can move to is within the allowed array. So now, what exactly is this allowed array? This allowed array is what we're discussing over here, and that is checkmate and legal moves functions. So what they basically are is basically an array of all the possible squares which the piece can move to prevent the check from happening. So what this does is, basically, first we need to generate whatever the allowed array is, similarly to how we did in the isCheckmate function. And then what we do is for each of the pieces inside the allowed array, so possible is basically the legal moves, and then what we basically do is we set the moves coordinates to equaling possible. So that basically means that the moves dictionary is basically all the possible pieces as well as the squares they can go to. But then what we need to do for them is we basically need to determine if the we need to determine whether that particular square is allowed. And then the way we do that, I'll just talk through. And then we basically just use that and then append it to the moves dictionary. Then after that, we just finally just return the moves. And this moves dictionary just gives all the possible moves, and then that's basically it for all possible moves. Okay, so that was basically it for all possible moves, as well as this also concludes all the legal moves, which we have to go through. And yeah, that's basically it for this particular video. I really hope you enjoyed watching this video. Hopefully you learned something new. And I very much hope to see you in another video next time. Thanks for watching. Bye.